Yeah, and the absolute basement of that cognitive evolution is the simple reflex agent. I mean, think of a basic reflex, like pulling your hand off a hot stove. It operates strictly on predefined if-then rules based purely on current sensory input. It
Exactly.
has absolutely zero memory of past experiences.
What's fascinating here is how quickly that architecture fails in a dynamic environment. I mean, to navigate reality, an agent must comprehend what it cannot immediately see.
Right, because what if the machine needs to understand context it can't immediately see? It needs something more.
It does, and that requires a model-based reflex agent. Instead of just reacting, it steps it up by maintaining an ongoing internal state. It tracks parts of the environment it can't currently see, predicting how actions affect the world and how the world independently evolves.
So it's essentially the coded equivalent of object permanence.
It really is. It represents the birth of machine memory and prediction.
But memory is great and all, but how does an agent actually decide what to do with that memory? I mean, it needs a target.
Right. Which brings us to goal-based agents. These are proactive, they're driven by specific objectives, and they use search and planning algorithms to find the most efficient path.
Wait, I'm confused here. So what does this all mean if there are multiple efficient paths? Is just reaching the goal enough?
Well, that's exactly the limitation of a goal-based agent. Let's go back to your GPS driving into that flooded river. It sees the destination and finds a valid route, but it doesn't care if the car gets destroyed just as long as it arrives. Utility-based agents solve this by essentially weighing the trade-offs.
Ah, so they use a utility function.
Precisely. They evaluate scenarios aiming for the best outcome by balancing competing factors like cost, time, and safety constraints. They prioritize nuance over mere completion.
So it's acting less like a stubborn missile and more like an investment banker hedging bets to find the absolute highest yield.
Exactly. It assigns a composite score to every possible outcome to maximize its optimal return.
Here's where it gets really interesting. Once you have an agent optimizing its own utility, it needs to adapt to moving targets, right? It has to scale up.
Right, which brings in learning agents. They don't just calculate, they improve over time. They achieve this using a critic to evaluate their performance against a set standard.
So the critic spots the inefficiencies.
Yes, and then a learning element updates their knowledge base from that experience, effectively rewiring the agent's logic to avoid repeating the mistake.
And when you need to scale that adaptation across a massive system, you deploy hierarchical agents, which is basically like a corporate structure.
That is a perfect analogy, actually.
Yeah, like you have high-level agents acting as the CEO, setting the overarching goals and constraints, while the lower-level agents are the departments executing specific subtasks. The CEO just manages the output.
Exactly.